Today I'm going to be making some improvements to a hold-down tool that I use to stabilize my hardy tools when I'm working at the anvil. Hi, I'm Dennis Frechette and welcome back. The hold-down tool that I'm improving is for my hardy tools at the anvil, and I made it about 15 years ago. I liked it. I've been using it for 15 years, so I really have no big complaints. But it is a little cumbersome to use. There's a couple of parts to it. There's a chain that actually links the hold down to the hardies. That's a little awkward to use. Sometimes it gets tangled up amongst a bunch of other things. It's kind of a nuisance. So I'm going to make a self-contained unit, which hopefully will fix a lot of the annoyances that I've had over the years. The overall system works great. I just need to streamline it a little bit, and that's what I have for you today. So hope you find it interesting. This whole idea got started when a friend of mine gave me a short section of H-beam, and I decided to use it to build a new base for my anvil. It was the perfect size. I was able to weld it to a heavy metal plate, so it was a really nice, stable unit for my anvil. And then at that point, I welded on a couple of brackets and some stuff that would allow me to attach a lot of different fixtures to this anvil base. And it soon developed into kind of the Swiss Army knife of anvil bases. Most of that stuff is gone now, but I did find a couple of the features to be pretty handy, and one of them was the hold down tool that I made for my Hardy tools. Now, the big problem with Hardy tools is that they have this built in design flaw, and that is in order to make them useful and easy to use, they have to be a loose fit. But the downside of that, of course, is when you hammer on them, they keep moving around. Now, the first idea that I tried was to install a turnbuckle to the base of my anvil, and this turnbuckle would attach to the bottom of the Hardy tool and apply a downward pressure which would keep it from bouncing around. And this idea did work for a while. Unfortunately, the hammering would tend to loosen the turnbuckle, and you were right back where you started. But at least it worked long enough to let me know that I was on the right path. The next thing that I tried was to just install a spring in between the turnbuckle and the base of the Hardy tool, and this worked great. The spring applied a constant pressure downward on the Hardy tool, and it also prevented the turnbuckle from turning, so you did have constant pressure, but it was really awkward to set up. And from there, I went to the system that I've been using for the last 15 years, which is a spring-loaded lever that attaches a chain to the base of the Hardy tool. So I'm getting a constant downward pressure, and there were no moving parts to work loose. So I was really happy with the whole idea. The only problem that I'm having now is that I am getting older and I'm finding it harder and harder some days to be able to work in that confined area and kind of feel my way around to setting up this chain. Most days it's not a problem, but I am getting more and more days where it takes me 2 or 3 tries to get this thing hooked up. So I find that I'm using this system less and less, especially if I'm only going to be using a Hardy tool for one heat, or I need to constantly be removing and replacing Harding tools while I'm working on something. So the only thing that I need to modify on this lever arm is to get rid of that little tiny fork that connects the chain to the lever arm. And I'm going to be replacing that with a bolt that's going to provide a fixed pivot point for the hook that's going to connect the lever to the base of the Hardy tool. The first thing that I need to do is to reshape the head of a standard carriage bolt. I'm going to be driving the head of the carriage bolt into a heading die that has a curved countersink around the outside edge. So this should make a really smooth pivot point for the base of the hook. I'm going to be making the hook from a piece of 1/2-inch square bar that's approximately 12 inches long. The heaviest part of the bar needs to be down near the base where the hook connects to the lever arm. There's going to be a 90-degree bend there, so I need to have enough material there to make sure that there's no chance of that bend straightening out. The other end of the bar just needs to taper down to a fine point that's going to hook into the Hardy tools. And the rest of this is just basic drawing down. I'm using the curved edges of my anvil to do a lot of the fullering, and I'm establishing the point first, and then I'm just going to keep working my way back down the bar until I get the length that I need. To establish the length that I needed, I temporarily put the bolt into the lever arm, and then I lifted the lever arm part way, and I measured from the top of the bolt to the base of my Hardy tool. And the Hardy tool that I used was the one that had the longest shank, so I measured from the hook on the bottom of that shank to the top of the bolt. And I'm going to be modifying all of my other Hardy tools to match that length. So here you can see how I have the hook attached to the lever arm, and the lever arm is back on the anvil base. The hook works exactly as I had planned, which is nice. It's easy to move around and it's really easy to set up on the Hardy tool. The hook does tend to move around quite a bit when I'm not using it to hold down a Hardy tool, so I will need to install some kind of a clip or a pin to keep it in one position so it doesn't move around and get in the way of other things going on at the anvil. So despite that one simple modification, I couldn't be happier with this hold down tool, and hopefully it gives you some ideas of how you can set up something like this on your anvil stand.